Hi everybody, tonight's video is going to be on slope. Slope is something that we've probably all dealt with before. This should be a review topic for most of us since we've all graphed lines before. Slope is the ratio of the vertical change to the horizontal change of a graph. So whenever I'm thinking of a ratio, I'm always thinking of a fraction. And when I'm thinking of the vertical change, I'm thinking of how the graph changes going up and down. And whenever I'm thinking of a horizontal change, I'm thinking of how it changes from side to side. So whenever we're talking about slope, we use the letter m as the variable. So m for slope. And if I'm thinking about a ratio, it's going to be a fraction. And it's the ratio of the vertical change to the horizontal change. You've probably heard it defined as rise over run before. That's a popular way to refer to slope. Another way that you can see this written is delta y over delta x. Okay, delta is a Greek letter, looks like a triangle basically. And in mathematical symbol language, it means the change of or change in something. So slope is rise over run, or it's the change of our y values, because remember y is like the vertical axis, is the y-axis is the vertical axis, to the change in our x values, which is the horizontal axis. When we're thinking of different types of lines and what kind of values we can get for slope, we can have a positive slope. So if I have a line that rises or goes up from left to right, the slope of that is going to be positive. If the line falls from left to right or goes down, like downhill, that's going to be negative. Slope can also be 0 or undefined. It will be 0 if it's just a straight horizontal line, right? So there's no change in the y values. They don't go up or down at all. So it's just a straight horizontal line. And then slope can also be undefined, and that's going to be a vertical line, one that goes straight up or down. It's so steep, there's no slope to define. Like there's no rise over run. There's no run, basically. So those are the 4 different types of lines you can see, and we'll talk a little bit more specifically about what their equations look like later on. If I want to determine slope, if I want to have a formula for it, it's going to be similar to our distance and midpoint formula. And I apologize for the dogs. They're making a little bit of noise in the background now. But just like we had with distance and midpoint, we're going to determine slope by using 2 points on the line. So slope is y2 minus y1 over x2 minus x1, where x1, y1, and x2, y2 are points on our line. So if we're trying to find the slope of a line, we need to find 2 points on there, and then we just plug them into this formula. y2 minus y1 is the difference of the y values, difference or change in. Difference we always think of when we have subtraction, just like sum is always the word we use to describe addition. So the difference or change in the y values, or the vertical change over the horizontal change. So if we want to do a couple examples here, let's say find the slope of the line containing or through, we'll say, the points, and we'll do a couple examples here. Let's do one real quick. We'll do -1, 2, and 3, 4. So if I want to find the slope there, I want to identify what's x1, y1, and x2, y2. And it doesn't really matter which one you pick as which, as long as you keep them, both these ones are both the ones, and these are both the twos, or these are both the twos, and that's both the ones. So the slope between these is y2 minus y1, so 4 minus 2, over x2 minus x1, so 3 minus negative 1. 4 minus 2 is 2. 3 minus negative 1, this is where we want to be careful when we're subtracting a negative number. That's really 3 plus 1, so that's 4. And so our slope here is 1/2. So why don't you try one now? Why don't you try finding the slope between 0, 6, and 2, negative 3. And so you can pause the video, do that example on your own, and then come back for the solution. So you can go ahead and pause it now. So again, you would identify your x1, y1, and x2, y2, and then plug them into your formula for slope. So m equals y2 minus y1 over x2 minus x1. So negative 3 minus 6 is negative 9, and 2 minus 0 is 2. So negative 9/2 is our slope. And it's okay, we're going to have fractions most of the time with slope. Keep it as a fraction. Don't put it into decimal form, like maybe if you're doing this in a calculator or something like that. We want to leave it as a fraction because we want the rise over run. Okay, sorry about that. I just had to pause it because the dogs were going crazy. Anyway, so slope can be a fraction, and we want to keep it as a fraction because it's going to describe our rise over run. And so I want to think of that top number as rise, bottom number as run. So I want to keep it like a fraction. The reason for that is if we are given the slope and a point of a line or point on a line, we can graph the line pretty easily. So once we find that slope and we leave it as a fraction, it's going to tell us how to move from one point to the other. So if we say, for example here, graph a line with the slope of, let's do a negative slope. Let's say negative 2/3 that goes through, let's pick the point, negative 1, 4. Okay, so we want to graph a line with a slope of negative 2/3 that goes through the point negative 1, 4. So this is pretty easy. I'm just going to go to the point negative 1, 4. So I go over 1 and up 4, and I plot a point. I want to graph this line. Slope tells me the rise over run. And when I have a negative slope like this, associate it with just one of the numbers. I like to just associate it with the numerator. All right, so let's just get in the habit of doing that. So it's negative 2/3 is how I'm going to think of a negative slope. And if this is the rise over run, the rise is telling me how I change up and down, and the run is telling me how I change left to right. So basically what I want to do is figure out how am I going to change on this line to get to the next point. So the negative 2 tells me that I'm going to change vertically down 2 units because negative would send me down, right? Positive is up, negative is down. So I'm going to go down 2. And now the run, or the horizontal change, is 3 units. And it's positive 3 units. So I'm going to move to the right 1, 2, 3 units. And that's where I'm going to put my next point. So slope is basically telling you how you change from one point to the next on any graph. So if you're given a point, you can use the slope to change to the next point. And then you would just get your straight edge. I'm going to draw this little freehand here. To draw a line that's through these points, you connect those 2 points, and that's your line. It passes through the point negative 1, 4, and it has a slope of negative 2/3. Okay, so we go down 2 and over 3. Okay, so that's a pretty simple way to graph a line given the slope and given a point of the line. And we're not even, in this case, not even worried about like what the equation of the line is or anything like that. Just want to graph it given this little bit of information. The last two things we're going to talk about are special types of lines, and there's special types of slopes. So horizontal and vertical lines. So like I mentioned in the first slide, a horizontal line has a slope of 0 because it doesn't rise at all. So when you think of the rise, or all of the y values are the same, right? Because it's just going across at the same y value. So y2 minus y1 would always give us a 0. And 0 over anything, our change of x, is going to be 0. So the slope is always 0 when we're talking about a horizontal line. With vertical lines, it's straight up and down. And for that, slope is undefined. And the reason it's undefined is because the x values all stay the same, right? So if I have the change in y over x2 minus x1, and the x values are the same, so if I have like a value of x is like 2, so 2 minus 2 would give me 0, so I have the change in y over 0, and so 0 in a denominator, we know we can't divide anything by 0, so that is why the slope of a vertical line is undefined. Now, here's where it gets a little tricky. With a horizontal line, the equation of the line is always of the form y equals some number. We'll just call it a, right? So a horizontal line always looks like that. So if you come across a problem that's talking about a line and says the equation of the line is y equals a, y equals some number, then that number is where your horizontal line occurs on the y-axis. And most of the forms of lines, which is the next video we're going to watch, are of the form y equals, right? So y equals mx plus b, that's something we've seen before. We'll talk about that later. So we're used to that, y equals a. If I were to say y equals 3, you're just going to draw a straight horizontal line at 3 on the y-axis. Where this gets a little confusing is that vertical lines have the equation of the form x equals a, where x is some number. This is a little weird because we're used to seeing like solving equations for x, and so when we see x equals some number, we just think like, oh, that's like solving an equation. We're solving something like just a regular algebra problem. But when it's talking about the equation of a line and we just say x equals some number, so x equals 4, that is a vertical line at 4 on the x-axis. So we're going to talk a little bit more about forms of lines in the next video, but I just wanted to show you these two and explain a little bit why the slope is either 0 or undefined for these two types of lines. So bring your notes with you to class tomorrow. We'll do some homework problems or classwork problems on the topic of slope, and I will see you then. Have a great night.